Cochran Marine Shore Power Systems for passenger and cargo vessels, powered by IEM Marine. Cochran Marine are the leading provider of shore power systems. We offer a patented solution that is proven, efficient, and reliable. Ports and shipping lines are under pressure to reduce emissions by minimizing diesel auxiliary engine use in port. Shore power protects port workers, ship's crews, passengers, local residents, and wildlife. Cochran Shore Power helps the marine sector meet environmental targets. Emissions. The Cochran Shore Power System delivers emission reductions. Modern diesel engines and fuels are better than previous generations, but current fleets of vessels using diesels are still regarded as heavy sources of pollution. LNG vessels are now being used to reduce emissions. However, technical issues prevent easy adoption, and LNG does have an environmental impact in extraction and use. Marine sources are 2% of all greenhouse gas emissions from transport. The marine sector is recognized as being very efficient, and import emissions are only a fraction of total marine emissions. However, harbor emissions are subject to close attention from pressure groups and legislatures. Airborne emissions from diesel engine use can be categorized as greenhouse gases, pollutants, metals and toxic compounds, secondary particulates, and ground-level ozone. Greenhouse gases. Greenhouse gases, including carbon dioxide and methane, are key contributors to climate change. CO2 represents 96% of greenhouse gases produced by the transportation sector. Methane is released when extracting natural gas, a disadvantage of LNG-fueled ships. During diesel combustion, methane is only emitted in small quantities, but it is 84 times more potent than CO2 for 20 years after release. Methane causes about 25% of man-made global warming. Pollutants include hydrocarbons, which contain dangerous compounds such as formaldehyde, benzene, and ethane. NOx and SOx both contribute to smog and acid rain. Particulate matter, which is the fine or ultrafine particles that can harm respiratory and cardiovascular systems. Metals and other toxic compounds from engine wear or the emission control process also affect the port environment. These include iron, arsenic, chromium, nickel, selenium, cadmium, and zinc. Many are harmful, causing respiratory problems and long-term disease. Concentrations of these substances are often higher in emissions where engines are running at idle. Secondary particulates are formed as a range of emissions mix in the air around the port area. Emissions reduction equipment can actually increase the production of these harmful compounds. Ammonium nitrates, often associated with exhaust scrubbers, cause acute and long-term effects on health, including damage to lungs, blood, and the gastrointestinal tract. Ground-level ozone. Ozone is a form of oxygen. When in the high atmosphere, ozone protects the Earth from the sun's UV rays. Ozone emissions can stay at ground level, combining with other compounds to form smog, harming respiration and damaging vegetation. This effect is common during warm and sunny weather, which promotes chemical reactions between NOx and volatile organic compounds. Improved engine design and efficiency. Emission scrubbers and better quality fuels are reducing the impact of diesel auxiliary use. New engines and exhaust treatments require significant investment, and further expenditure could be required to meet future regulations. The centralized generation and distribution of electricity, accessed through shore power, is significantly more efficient and less polluting. By using grid power, ports and shipping lines employing shore power will keep up with the latest advances in green energy generation. What is shore power? Shore power, or cold ironing, allows vessels to transition from auxiliary power to grid electricity when in port. The Port of Long Beach says that this approach reduces atmospheric pollution by 95%, improving the environment for people and wildlife in the port area. Cochran Marine and IEM Marine have 10 years' experience in delivering shore power. The Cochran Marine system supports the sustainable operations of the port and the vessels that visit it. The Port of San Francisco calculates that the reduction of harmful emissions for a single 10-hour cruise ship call includes 140 pounds of diesel particulate matter, 1.3 tons of NOx, 1,700 pounds of SOx, and almost 20 tons of carbon dioxide gas. The demands on a shore power system. Cochran shore power systems are designed around the needs of each port and the shipping lines that use it. Essentially, the system must be available for every visit to the port, connect to different vessels safely and effectively, step down high distribution voltages, condition the power supplied to the vessel, deliver measurable benefits, principally reduced fuel use and lower emissions, provide uninterrupted power during the connection. This applies to cruise ships in particular, and manage any differences in frequency between the local grid and the vessels connecting to it. The Cochran Marine Shore Power Standard Design. The Cochran Shore Power System is based on a standard design with options to meet the specific demands of each application. Every system includes a primary section, voltage frequency management section, secondary section, and the dockside equipment. Cochran Marine Shore Power 50 Hertz dual voltage output system. Most ships operate at 60 Hertz, but many ports around the world are at 50 Hertz. The design for 50 Hertz system includes frequency conversion to create compatibility. The standard Cochran Marine 50 Hertz integrated shore power system comprises the primary section, including the utility input, a voltage and frequency management section, including the step-down transformer, a frequency converter, and the step-up transformer. Secondary section, including the main protection and automation systems. The dual output lineup provides two alternative voltages, one at 11 kV and the other at 6.6 kV. This provides the flexibility required for cruise ship shore power installations. The final section includes dockside controls and the cable positioning system, with the connection cables that will carry power to the ship. The components of a 60 Hz dual voltage output Cochran shore power system. A primary section, which is identical to the 50 Hz system. A single transformer. No frequency converter or second transformer is required in this design. The secondary section, including protection systems and the automation controls. And the dockside control cabinet and cable positioning system. The components of a 50 Hz Cochran shore power system, single frequency and output for cargo vessels. Primary section with the input feed. A voltage frequency management section with transformers and frequency converter. Secondary section, including protection systems, automation controls, and a single voltage output. Cargo ships usually operate at 6.6 kV, and therefore they do not require a second output at 11 kV. And the shoreside cable connection apparatus. The 60 Hz Cochran shore power system with a single frequency and output is made up of a primary section, which is similar to the 50 Hz cargo specification. A single transformer with no frequency converter required. The secondary section, including the system's protection systems and automation controls. And, at the shore side, the power connection equipment. We can work with you to fit or retrofit the necessary shipboard equipment to connect to the shore power and safely distribute the power around the vessel. Cochran Marine Shore Power, an integrated approach. A successful shore power system isn't just about equipment. Cochran Marine's shore power expertise will help you develop and implement your system, from the consulting stage through the whole design and build process to system implementation and successful operation. Cochran works closely with IEM Marine, who will manufacture and test your system thoroughly in their advanced facility before it is sent to the site for installation. Cochran Marine Shore Power, end-to-end project management. On the shore side, Cochran organizes and oversees the unloading and sighting of the system. A minimum of shipping splits helps ensure quality and saves time during installation, commissioning, and final on-site testing. IEM Marine's build process and rigorous factory testing reduces the risk of issues at startup and maintains site safety. Throughout the process, the Cochran Marine team will be on hand to ensure the smooth running of the project. Cochran Marine Shore Power, ongoing commitment. After installation, Cochran Marine will assist with operations. A trained operator handles the connection process as each ship arrives in port. Your team are taught the connection procedure to help maintain safe and effective connections. Every connection is overseen from Cochran's dedicated control room by experienced marine engineers. Our engineers monitor over 500 connections each year, providing live support for the on-site teams. Cochran Marine provides comprehensive servicing and maintenance for your system. Cochran Marine Shore Power System Operation. A connection using the Cochran Shore Power System proceeds as follows. The system confirms the ship's unique information before arrival at the port. The Cochran operator helps align the vessel with the dockside connection point. The Cochran shoreside operator verifies the safety of the connection. The operator verifies readiness, orients the cable positioning device, and, with the automation system, determines the operating parameters for each vessel. The ship and shore teams work together to make the physical connection. Once the ship is plugged in, final checks are made and the operator waits for a go-ahead from the ship before sending power aboard. Our design ensures that connections are completed without interruption to power to the ship. Every connection and disconnection is supervised by our engineers operating from the Cochran Control Center in Seattle. The data gathered across thousands of data points is collated and the system reports key metrics. Cochran Marine Shore Power Information Reporting. Once the shore visit has ended, reports are generated. The reports will help management understand each vessel's energy use and support decision-making around the overall strategy for reducing emissions. They will provide evidence about emissions savings and could be used for marketing or public relations. The reports are customizable and include details of the port visits, energy use and emissions reductions, and Cochran Marine also uses the data to improve future power system performance. Cochran Marine Shore Power Case Study, Port of San Francisco. The San Francisco shore power installation came online in October 2010. This dual-voltage system uses an IEM switchgear lineup and provides both 11 kV and 6.6 kV power via two fixed dual-voltage cable positioning devices. The systems can power two cruise ships simultaneously. Cochran Marine worked closely with stakeholders, including the local utility provider, to ascertain and deliver the appropriate level of power for the project. Cochran Marine acted as the general contractor, providing design and pre-construction support, equipment procurement, contractor management, and commissioning support once the system was installed. By using the Cochran Marine Shore Power System, the port has reduced greenhouse gas emissions equivalent to thousands of tons of CO2 and removed a range of potentially hazardous airborne compounds from the port area, as well as reducing noise and vibration levels. Cochran Marine's after-sales support will help your shore power installation remain in excellent condition and providing long-lasting benefits. We have dedicated equipment to test and maintain your shoreside and shipboard power system and expert engineers to deliver on-site technical support. Cochran will provide expert field maintenance of your equipment to protect your investment. And remember, every connection has live support from our specialists in our Seattle Control Center. Cochran Marine offers a one-stop, single-provider approach for your shore power solution. We support your project every step of the way through to successful implementation and operation. Advantages of the Cochran Shore Power System include end-to-end commitment, control over design and construction, equipment designed for port environments, fully factory-tested products, commissioned and operational in days rather than weeks, easy vendor management, simple and reliable shore power connections managed by experts, reporting on key metrics. And with our system being standardized and highly reliable, it is readily maintained and upgraded. For further information on our shore power systems, please contact Cochran Marine on +1 206 755 4622 or visit www.cochranmarine.com.